Okay, so this is the building block. This is the incoming DC voltage. This is your fuse, and this is your DC to DC converter section. This will convert the DC to this through this inductor, and then the DC is further rectified through this. Yeah, the rectification is done by the body diodes of these IGBTs, and then the IGBTs later convert it to AC. That's for the inverter section. Now, for the battery charging section, the incoming DC or AC supply comes in through this. Where is it? Uh, this is output. This is output. It comes in through here, through these two. This is filtering lines. This a whole of this will filter it. These are MOVs to clamp down excess spikes. Then when that comes in through the filtering section, it passes through this for IGBT. This will form an H bridge, which will now convert that power at high frequency AC, pass it through this ferrite core. The ferrite transformer will now send out the voltage to this H bridge. Now, it's not the full H bridge that will work. A part of it will work, will oscillate, and then rectify that voltage that will be used to feed this terminal and charge the battery that's connected to this board. So now, there's another section of this board that has to do with initial startup power and the main power. Now, this is the transformer that is going to connect to this high bus voltage. Normally, if this is faulty, you will have a fault F09. Similarly, if any of them is faulty, it can lead to fault F09. If any of this is faulty, fault F09 is also gonna come up. Fault F09 can also come if this is bad or this is bad. Now, before I go further, this board comes with an hybrid system. This side is where your solar is connected. The solar input comes in here, gets filtered along this line, and the design, the topology they are using here is I think this is a buck boost topology where the converter can either step up the voltage or step down the voltage. So this will take in maybe a high voltage of up to 200 or 300 or thereabouts, convert it down, push it to these capacitors. There's a relay here that does the connecting and disconnecting of the system. Push it in there, and that in turn will flow through and charge the battery. Now, if you have a dead set situation in this board, you should look at this circuitry. This circuitry should be default. Check here. If you should have fault F09 or 53, look out for this circuitry. This IGBT may be faulty. You can also check that this component, the circuitry that is connected to this, they are all okay. If you should by any case have this one blown, if this guy here is blown, please also try to replace this and a whole lot of other things, you get. So if you have any question, you can feel free to drop it in the comments. I will be able to clarify issues for you. Those are the basic problems that are common. can also have a burnt fuse. If you have a burnt fuse, don't bother yourself. Make sure you replace these MOSFETs and the accompanying driving circuits, which are here. These are the driving circuits. Replace them, and then don't stop there. Go a bit further to test this IGBTs. All of them, from this one here down to this one. Most of the time, when this one here is bad, this one is the one that's triggering the fault. And in my experience, the grid power supply in your environment might be poor. That is why this will go bad and will force these ones to go bad. Yes, because it will form a short circuit. This will not be able to power the load. So you should look out for that. If you are doing an off-grid system where there's no grid connected to it and you are having a faulty system with code F09, it is possible that there are two things that is causing that problem. You should check here, this high voltage signal from solar, check this charge controller, and also check the output section, the edge bridge section for your inverter output. You will see the fault there. Code 53, 51, F09, they are all related. So you can check those places to resolve that issue. Most of the time, it's caused by failed IGBT and other switching components in the driving section. Once you resolve that, the fault is gone. 100% sure.